There are few things we need to focus: electromagnetic and induction. Okay, electro means, can I simply say electron? Okay, with the help of electron, can I say there is a word called current? You need to interrelate everything, huh? Current with voltage, and with the all these things we have the word called electric field. Yes or no? All these things are connected. Fine. Okay, with the magnetic we have a simple word which is called B. Induction means production of current. Production of current in opposite direction. Fine. Again, in terms of electro, we need to focus on few things, either on charge. Sometimes we are going to learn about the current, sometimes voltage, and sometimes electric field. Even in case of force, we can use Q, E. These all are the factors which are going to relate with the magnetic field. Okay, so if you remember from the previous days or the term 1 and term 2, as you know, if there is a wire, let's say case 1, there is a wire, okay, and if the current is flowing through the wire, this is your current. Okay, if the current is flowing through the wire, we know magnetic field is produced. Magnetic field is produced in the wire. Clear? But now the same thing can happen, the opposite of this. What is the opposite of this? Can I say change in magnetic field can produce current? Just try to understand. Change in current gives you magnetic field. My question is, can change in magnetic field gives you current? And the answer is yes. And this is the all we are going to learn in this lesson, that what is electromagnetic induction. So what is the short form of electromagnetic induction is? Electromagnetic induction is EMI. What is electromagnetic induction? That process of producing induced current. Induced current means we are going to produce the current in opposite direction. Okay, let's say with the you can say with the notes, with the help of notes you can understand. So the first part, I already told you, can moving charges produce magnetic field? Yes, we already learned this thing in the term 1. Okay, second part, can moving magnets, okay, or the changing magnetic field, moving magnets or changing magnetic field produce current? Yes, and this is the thing we are going to learn today in this class. Okay, so this experiment means the proof of this experiment has done by, there is the British physicist Michael Faraday, and there is one more American physicist, Joseph Henry. So these two person has made some experiments and prove that if you change the magnetic field, that will produce some current, and that the current name is induced current. Okay, now what is the conclusion of the experiment? Now just focus here. I will use the blue color. Changing magnetic field. Okay, magnetic field is keep on changing, and what it is doing? Generating a potential difference. So means generating a potential difference which is directly proportional to current I. Okay, in a conductor which is strong enough, means we are producing potential difference which is responsible to produce an electric current. Fine. Now we will go step by step to understand this whole process. The first thing, EMI. I told you what is the meaning of EMI? Electromagnetic induction. What is electromagnetic induction? Process. What process? Of generating induced current. Induced current means in opposite direction. In opposite direction. Okay, in a conducting circuit by changing. Okay, there are the factors. You need to focus on this part. Huh? What are the factors? Number one, strength. Strength means magnetic field. Magnetic field. This is the strength. Okay. Number two, position. In terms of position, we are changing the area. Third is orientation. Orientation means the angle. We are changing the angle theta. So if we change these three things, either magnetic field, area, or the angle theta, there is a change in the system and the current will be produced. Fine. Okay. Now there is a word called flux. Flux means, okay, I will explain you on the next page so that you can relate this. Add a page. Okay, now remove this. Now the word is called magnetic flux. What is the meaning of magnetic flux? Magnetic flux means, let's say there is an area, okay, and how many, let's say this is a magnet. This is south, this is north, and the line of forces are passing. Yes? Okay, remove this one, because it is crossing. Okay, now the line of forces are passing. So how many line of forces are passing? That is called magnetic flux. So number of line of forces passing through unit area. Clear? So can I say flux? The symbol is phi. Okay, the first factor is magnetic field, which is equals to B. Second is area A, and there is an angle which is called cosine theta. So flux is BA cos of theta. If you remember, I just told you EMI, and I told you there are the three factors. Number one, magnetic field, that is the strength, yes or no. Number two, position, which is the area. Third is the orientation, which is angle theta. So if I combine them together, can you see here what we get? We get the flux. Yes or no? Do you understand this part? So if I say change in flux, change in flux give you the result as a induced current. Now till here, do you understand, guys? Change in flux gives you induced current. So, or you can say it gives you induced voltage. Clear? Sure. Okay. So we are going to learn about this thing. So flux is equals to BA cos of theta. Okay. In this, I need to add something which is very, very, very important. You should know the word called quantities. Okay. We have the word called vector and we have a word called tensor. Okay. Why I'm going to explain you this? You just after 5 minutes you will understand, because I need to relate this with the cases of magnetic flux. Let's say if I say vector A. So how I will write A, this is the magnitude. Okay. And A cap, this is the direction. Fine. But if I write here A vector, which is equals to A, this is your magnitude. And here is n cap, which is the direction. But now there is a major thing what you need to understand. Here the direction is same. Direction is same. What does it mean? Let's say there is a body, and if you apply a force, this is the force vector. Okay. So can I say this is the direction of force? So I can say F vector is equals to F magnitude, which you are applying here, and the direction is the same. Direction is the same. Clear? So that's why it's a vector quantity. This is a vector. But here, what is the difference? What is the difference? You can write here like theta is equals to 0 degree. Here what you can write, theta is equals to 90 degree. Now you will understand what is the logic and what is the other name of this one. If I say magnitude and direction, let's say this is your surface. This is the surface. Okay. So what is the direction of this surface? Can you say the direction of surface is this one, n cap? Yes or no? So it is at the 90 degree of the base. It makes an angle of 90 degree. Similarly, this is the case 1. Okay, let's say case 2. If I make a surface like this, okay, where should be the, or you can just understand your hand. Okay, so where is the direction? Like this. This is your n cap, which makes an angle of 90 degree with the surface. Fine? Clear? So that's why n cap is called normal vector. Normal vector. Fine? Okay, this is a tensor quantity which has a property of scalar as well as vector at one time. I'm going to add a page for you guys, and then I'm going to explain you the concept of magnetic flux. So till now we understand magnetic flux. Magnetic flux. Yes or no? Okay. So we understand phi is equals to BA cos of theta. Now what we need to understand, there are the two factors. B is a vector. So can I say B cap? This is your magnetic field. Okay. A, which is area. This is your area vector. So area vector A is equals to A n cap, because it's a tensor quantity. So you can say n cap is your unit vector, but it's a normal vector. Normal vector. Okay. Now there are the cases, because these cases are going to use in the numericals. So it's very, very, very important to understand. Okay. Now the case 1. Let's say if you have a surface, case 1, if you have a surface like this, and how this type of surface will come in your numerical. Okay, so I'm going to write that when magnetic field is perpendicular to the surface, you will get this same statement in the numerical. Okay, they will give you that magnetic field is perpendicular to the surface. How you are going to solve this situation? Let's say this is your magnetic field. Yes or no? So what is the angle here? 90 degree. But there are two things. One is A, which is called the area. Yes. And one is n cap, which is the direction. Now this is very, very, very important, what you need to understand. Okay, B makes an angle of P. B is magnetic field. Okay, so B makes an angle of theta of 90 degree with A. Do you understand? With the surface. Do you understand? Now my question is, what is the angle between? What is the angle between B cap and N cap? Okay, this you understand, this is your B cap. But where is the N cap? Tell me. This is the surface, and I told you N cap should be like this. So B cap is like this, N cap is like this. So what is the angle here? Can I say both are in the same direction? Angle is 0 degree. Yes or no? It is making an angle of 90 degree. Perpendicular means theta equals 90 degree. With whom? With surface. Not with direction. It is making 90 degree with the surface. Fine guys, clear. So if you solve the flux, what is the flux? B A cos of theta, and theta is the angle between B cap and N cap. Is it clear? B cap and N cap. So I can solve flux is equals to BA cos of 0 degree. So which is equals to BA. So it is called maximum flux. Fine. Clear. Okay, now case number 2. This is very important, guys. So at least if you don't understand, you have to review it 2 times, 3 times, 4 times. You have to make some mastery, then go for the numericals. Else you will get confused. Okay. Now the case number 2. Let's say when the magnetic field. Case number 2. When magnetic field B is parallel to the parallel to the surface. Okay, first of all, you need to understand. Let's say this is your surface. This is the surface. Okay, how? Parallel means, okay, can I draw like this? This is your magnetic field. This is the B vector. So can I say here is your B cap? Fine. So you can say, what is the angle here? With the surface, parallel means theta equals to 0 degree. So can I say B and A? A means area and B is your magnetic field. So what is the theta here? 0 degree. Fine. Okay, now just tell me, think and tell me. This is your surface. Okay, so where is the angle? N cap. This is your N cap. Yes or no? This is the first part, second part. So do you understand? This is your B cap and this is your N cap, perpendicular. So making an angle of 90 degree. So theta is equals to 90 degrees. So flux is equals to BA cos of 90. So cos 90 is 0. Flux is equals to 0. This is called minimum. Fine guys, do you understand? Sure. Okay, now this is the case number 3. What you need to understand, that is most important, which will kill your brain. Okay, let's say there is any angle theta, between magnetic field and surface area. Okay, what you need to understand, let's say there is a surface, okay, and let's say this is the magnetic field is going. Clear? So let's draw the diagram. Okay, so it is making any angle theta. Let's say you can say 30 degree. So where is the N cap? Where is the N cap? Or what is the real angle you are going to use? So with N cap and B cap, your angle is 90 minus theta. So if 30 is given, so what you need to do? Theta is equals to 90 minus 30, which is equals to 60 degree. So flux is equals to BA cos of 60 degree. This is very, very important. And in lots of numericals, you will get this thing. Clear? So how to solve all these things? Now you understand? Okay. So we are solving flux, which is BA cos of theta. So what is the unit? If you solve it, the unit is SI unit is Weber. SI unit is Weber, or you can say Tesla meter square. Tesla meter square, or you can say joule per ampere, or you can say volt second, and the dimensions are m1 L2 T minus 2 A minus 1. Clear, guys? Till here, I thought you will understand what is the concept of magnetic flux and how you need to solve them. Clear? Okay. Till now, we have learned flux is equals to BA cos of theta. Okay. Now, what exactly we need to understand? We need to focus on the word called induced EMF. Induced EMF, or that is also called Faraday law of induction. What is Faraday law of induction? Faraday law of induction said V induced is equals to negative d phi by dt. Negative d phi by dt. Okay, we need to understand few factors here. We know flux is equals to BA cos of theta. Okay, so if the flux is changing, how many factors can change? There is a possibility of 3 factors. Number 1, B can change. Number 2, A can change. Number 3, theta can change. Let's say theta is equals to omega t. That is from the angular motion. Angular motion. You need to understand. Let's say there is a circle. Okay, make it a little bit big. Fine. And a body is here. Let's say point A. You are moving till point B. So you are facing an angle. You are making an angle theta, and you are moving with angular velocity. Omega is your angular velocity. Okay, and t is your time. So can I say distance is equals to speed multiply time? So what is the distance here? Your theta, which is equals to omega times t. Okay, and one more formula for omega. Omega is equals to 2 pi by t. 2 pi by t, or you can, from this equation you can say omega is equals to theta by t. If you are using a full circle, you are solving with full circle, then theta equals to 2 pi. So you will get this formula, omega is equals to 2 pi over t. And one more equation, as you learn, theta is equals to omega t. Omega is equals to 2 pi by t, and we know word called frequency. Frequency is 1 over t. So can I say omega is equals to 2 pi over t, or 2 pi f? Because in the numericals we are going to use all these things, so you should have a basic idea how to solve them. Clear? Okay, now guys, one by one. Let's say when there is a change in magnetic field. First factor, change in magnetic field. Magnetic field. Then how things will be, or how you can say the induced current is produced. Okay, so can I simply say V induced is equals to negative d phi over dt? Yes or no? Negative. Which factor is changing? Magnetic field. So keep that one aside. So A cos of theta, can I say dB divided by dt? Yes or no? Easy, because only one factor is changing. Okay, second one, let's say now area is changing. Area is changing. Then what will happen? Keep area at the back and solve it. So V induced is equals to negative B cos of theta dA over dt. Yes or no? Fine. Okay, now the third one, I told you in terms of angle. Change in angle. Okay, the first thing, theta should be omega t. Why I'm doing all these things? Because we induced, what is the value we induced? Negative d phi divided by dt. So you need something in terms of t so that you can change it. Okay, now we induced, which is equals to negative a b, or you can say ba, that is much better. B magnetic field, A area, d by dt of cos omega t. If you solve it, what will you get? Negative BA. If you solve, okay, I will solve it in the separate section for you so that you can understand, and I can write the direct formula for you. Okay, d by dt of cos omega t. So for the cos, you will say there should be a sign, yes or no? Negative sine omega t. Then d by dt of omega t. Then what will you do? Negative sine of omega t. For omega t, you will get omega. So can I say negative omega sine of omega t? Fine. So just change the color. So I will write here negative omega sine of omega t. So what is the value? Positive omega b a sine of omega t. Clear? You get all the three equations. First equation, second equation, and the third equation. On the basis of all these three equations, you can solve your numerical, and you just need to check which factor is changing. Either there is a change in magnetic field, either there is a change in area, or there is a change in angle. Fine. Okay, this I already covered with you, which is the important one for your understanding. Magnetic flux I already covered. Faraday law I already covered. Okay, now we have the questions and you need to focus on them. Okay, now guys, read the first question. This is the interesting one and you will love it. Focus, huh? The plane of the circular loop, okay, is shown in the figure is perpendicular. Focus, again focus. The plane means area. Plane means area. If you remember, I told you flux is equals to BA cos of theta, and if you remember, I told you there is a tensor quantity and the vector quantity. So whenever we are checking the angle theta with in between n cap and a cap, yes or no? Or n cap and b cap, n cap and b cap, not between area and magnetic field. Area and magnetic field, because with area and magnetic field we will not get the right answer with the direction of area. Okay, the plane of circular loop shown in the figure is perpendicular. It means theta should be 0 degree. Yes or no? I'll show you how. If you remember, that is very good. Even in the video I covered this thing. Okay, let's say this is your area. I'll make it in a proper way so that it should be clear. Okay, this is your area. Now this is your magnetic field. Clear? Now what is the direction of area? Tell me fast. Okay, this is the direction of, you understand now? So it becomes theta is equals to 0 degree, and area and magnetic field are theta equals to 90 degree because they are perpendicular to each other. Fine. Okay, this is very important in the numericals. You need to understand what should be the angle. So the first thing given is theta is equals to 0 degree. Okay, now continue. The plane of the circular loop shown in the figure is perpendicular to a magnetic field with B. B is given 0.5 Tesla. The magnetic field goes over 0 at a constant rate in 0.25 second. Okay, now what we need to understand, is the magnetic field changing? Yes, there are the two factors, initial and final. What he said, we have magnetic field 0.5 Tesla and goes to 0. So B initial 0.5 and B final is your 0. Yes or no? Because he said it goes to 0. Similarly, your time, he said it takes 0.25 second. Let's say it starts from 0 second, t initial 0 and t final is your 0.25 second. Yes or no? Understand? Okay. The magnetic field goes to 0 at a constant rate of 0.25 second. The induced voltage, okay, that is given, induced voltage, second, third, V induced is 1.24 volt during that. What is the radius? What is the radius? Fourth factor, we are looking for radius. Clear, guys? Till here. Okay. The first, what is the formula we are going to use? Magnetic field is changing? Yes or no? So we are going to use this formula. Magnetic field is changing. So can I say V induced? Okay, I need to use the space carefully now. First is V induced. V induced is equals to negative A cos of theta dB by dt. Okay, so area is equals to pi r square and we are looking for r. Okay, V induced is given how much? 1.24, which is equals to negative pi r square. Okay, cos theta we already solved, theta is 0 degree, theta is 0. Then can I say cos 0 degree is 1 multiply 1 dB by dt. dB by dt. So what is dB by dt? Final minus initial. So 0 minus 0.5 delta B divided by final 0.25 minus 0 dB by dt. Okay, solve it, place the values, place all the values. So you will get r is equals to, you can place all the values, you can use pi is equals to 3.14. So place in the calculator, you will get r is equals to 0.444 meter. You will get r is equals to 444 meter, 0.444 meter. Clear, guys? You understand the concept? Okay. Now the second one, that is more interesting one. The current, and we need to understand what is the changing factor. A current of 600 milliampere. Okay, I'll use this area for the given so that we have more space to solve. Okay, let's say current I is equals to 600 milliampere. Can I say 600 milli means 10 power negative 3 ampere. Okay, this is your factor number 1. Okay, fine. Is flowing in ideal solenoid. Okay, guys, in terms of solenoid, you should know what is the formula. B is equals to mu naught N times of I. What is N? Capital N by L. Mu naught capital N by L times of I. I already given here also for you guys. See, this is for solenoid. Okay, mu naught n small n I or mu naught capital N I divided by L. Fine. Okay, resulting in a magnetic field. Magnetic field is given, third, B is already given. What is the magnetic field? 0.025 Tesla. Inside the solenoid, it is always maximum. Remember this thing, inside B is always maximum. So can I say it is equals to your B naught? This is the maximum value. maximum value. Okay, inside the solenoid, inside, then the current increases with the time and there is a factor. Okay, it is given I is equals to I naught bracket 1 plus 2.4. Okay, second inverse square, no need, time square. Okay, if a circular coil of radius is given 3.4 centimeter, so 3.4 times 10 raised to 1 negative 2 meter. Okay, conversion with capital N. Okay, capital N is your 200 windings, is located inside a solenoid with its normal vector, with its, this is the major point, normal vector means, what is the meaning of normal vector? Normal vector means n cap. What he said, now just focus, parallel means angle is okay, change the color, angle is theta is 0 degree. Now you understand normal vector, it is not talking about the area, it is talking about the directly n cap. Okay, with the magnetic field. Now you understand. Okay, your theta is equals to 0 degree. What is the induced potential difference? We are looking for V induced. Okay, and time is equals to 2 seconds. Clear, guys? Till here everything is clear. Now we understand that I is there and I is changing. We know as per ideal solenoid, B is equals to mu naught n I. So I is directly proportional to magnetic field. You need to focus on this point. So can I say what is the equation for magnetic field? B is equals to B naught 1 plus 2.4 T square. Use this equation and now we are going to solve it. So just solve it step by step. So we induced, okay, I'll make a line here so that it will be easy. V induced equals to negative, okay, A cos theta dB divided by dt. Clear? Okay, now place the values and solve them. So we have the area. For area we can solve it. Area is equals to pi r square, yes or no? And there are the 200 windings, so can I say multiply with capital N? Okay, 3.14 times, what is the radius? Radius is given, so 3.4 times 10 raised to 1 negative 2 square, multiply, N is 200. Solve this value, jaldi, fast. So you will get 0.73 meter square. Fine. Okay. Second factor, cos 0 degree, which is already equals to 1. Third factor, dB by dt. You need to solve it here also. First factor, second factor, third, dB by dt. D by dt. Oh, what is the value of B? B naught. B naught we already have. I told you the maximum value. 0.025 bracket 1 plus 2.4 t square. Okay, solve the differentiation. So can I say 0.025 outside, 1 is 0 plus 2 multiply 2.4 t. Okay, and t is given in the question. Time is given 2 seconds. Put it here. Can you place it here? Okay, now just place it here and solve it. So we will get an equation. V induced, okay, I'll change the color. Negative A is negative 0.73 multiply 1 multiply bracket 0.025 multiply 2 multiply 2.4 multiply t. Place the value t equals to 2. So you will get V induced is equals to. Now guys, solve this. So what you will get? You will get negative 0.18 volt. Just place the value of t is equals to 2 seconds and multiply them. You will get this value. Fine, guys. You understand? Now we have the numerical, and let's start with this one. Concept check 9.2. But guys, on the one page, I have two numericals for your notes, but I have already separated them. So I will start from here. Okay, a power supply is connected to loop 1. Okay, this is your loop 1, and an ammeter. Okay, here is an ammeter as shown in the figure. Loop 2 is close to loop 1. Okay, this is the loop 2 and is connected to a voltmeter. Okay, there is a voltmeter. A graph of the current I through the loop 1, current I through the loop 1 as a function of time is also shown in the figure. Which graph best describe induced potential difference in loop 2 as a function of time t? Okay guys, there is a very interesting thing what you need to understand. The first graph is between I and t. So let's say in any graph, okay, let me explain here. In any type of graph, there are two things what you need to focus. One is the y-axis divided by x-axis. Okay, so what is this? This is called slope. And second is if you multiply them. If you multiply them, y-axis multiply x-axis, that is called area under the graph. Area under graph. Clear? Okay, here the first graph you have, that is, if you check clearly, that is between I and t. I versus t. Here is I, here is t. And second graph, the resultant graph, where you need to find the result, that is between the v and t. V and t. Okay, so if I'm looking for the slope, so I divide by t, here v slope, v divide by t. I know what is this? This is called flux. You know, v induced is equals to d phi by dt. So can I say phi is equals to vt? Yes or no? Here we know I is equals to q by, what is this? Just try to understand. I divide by t. In terms of I, we need to check. Okay, let's see here. What is happening here? We know whenever the one factor is increasing, another factor is decreasing. Here should be negative. Here should be negative. Okay, now just focus here. Current is increasing. Yes or no? Take this point. 1 point, 2 point, 3 point, 4 point, 5 point. Okay, these are the factors we need to check in terms of flux. So if the current is increasing, just check what is the induced current. What should be the induced, or you can say the flux, that should be the negative. So for this factor, we have this one. Check this value. Do you understand? Okay. Second point. Check this point. This is your second point. Then when it is declining, this is decreasing, current is decreasing, flux is increasing. Here it is increasing, here it is decreasing. Clear? Or you can say just the negative one. So your answer number, graph number 1 is correct. Fine. Try to just imagine in your brain V induced is equals to negative d phi over dt. So you need to check if current is increasing in loop 1, current 1 is increasing, then current 2 should definitely decrease. I told you na, it is opposite in nature. If one is increasing, second is declining. And if the first one is declining, first one I1, then the I2 should increase. Clear? Understandable? Okay. Now we have the another question. This is something very, very interesting one. You need to focus on. A rectangular. Okay. So with the word rectangle, we need to focus. A rectangular. So in terms of rectangle, what is the value of area? Can I say length multiply width, length into width. Okay, so L times W. A rectangular while loop of width W is given. W is given 3.1 centimeter, which is equals to 3.1 times 10 raised to 1 negative 2 meter, and depth D naught. D naught is given 4.8 centimeter, which is 4.8 multiplied 10 raised to 1 negative 2 meter, is pulled out. This is the keyword for you, huh? Is pulled out of the gap between the two permanent magnets. Okay, what you need to understand, let's say this is the complete body. Okay, and if you take it out first, where it is here, yes or no? It is like this. Now you are pulling it out. So what is the new situation? The new position is this one. Do you understand? This is your new position, means some part of this is comes out. Clear? Okay, it means there is a change in length. What is the understanding here? What is your understanding? That some part of whose part, you can say some part of length is reduced. Yes or no? Try to understand again. This is your first value. This is the length and this is your width. Just try to understand. This is the width W and this is the length L. And now if you start pushing it, it is coming out. Now what is the new situation? Try to understand. Now it is like this. So width remains the same, na? This is the width. W remains same. Yes or no? But what is the change? What is your new length? From here to here. This is your new length. L dash. Clear? Sure? Okay. Now so that you can solve it, huh? Okay, magnetic field is given. B, what is the value? 0.073 Tesla. Present throughout the gap. If the loop is removed at a constant speed, okay, speed, velocity is given 1.6 centimeter per second. Okay, what is the induced voltage? Okay, we are looking for V induced, which is equals to minus d phi over dt. Flux is equals to BA cosine theta. What is the as the loop functions of time? Okay, angle is not given, then we can generally take theta is equals to 0 degree because it is going parallel. Okay guys, now we need to understand the major learning part. What is the learning part here? That area is changing. Area changing. Yes or no? Because length is changing. Clear? So what is the area here? Area should be the length into width. What is the new length? New length or new area. So can I say the new length should be, new length L dash should be equals to, what should be the new length? Let's say complete length is D naught minus V times T. Okay, wait. If you don't understand this thing, I will tell you. Let's say this is the length L, original length L, which is equals to D naught. Fine. Okay, now you have shifted like this. So you have to find this part and this part. Can I say L dash? But how much you have shifted? Just tell me, what is this part? Can I say length? Generally, the formula of length is, or generally the formula of distance. What is the formula of distance? Distance is equals to speed multiply time. Yes or no? Okay. So can I say this L dash is equals to speed is velocity multiply time. So what is the total value? Can I say L dash is equals to D naught? This is the original value minus velocity time times. Clear? You understand this part? This is very, very, very important. Okay. So what should be the new area? New area. So it should be new length multiply width. So what is the new length? You have d naught, or you can say w, first put it w so that it's become easy, width d naught minus vt. Clear? This is a new area. So now just solve the question. So we have v induced is equals to minus d phi over dt. Area is changing. Okay, negative b cos of theta dA by dt. Clear? Okay, now time to solve it. What are the values? Okay, negative b. Okay, cos of theta we already know. Cos of 0 degree is 1. Negative b d by dt. What is the value of a? W, width d naught minus vt. Okay, solve it here so that you can solve this part. So d by dt of w d naught minus w vt. So here is no t factor, 0 minus vt. Okay, w v. So this is the derivative. Okay, with negative sign. So can I say negative b bracket negative w v? So can I say positive b w v? Yes or no? Okay, now place the values. What are the values? What is the value of b? Value of b 0.073. 0.073. Okay, what is width? Width 3.1 centimeter, or you can put in the, okay, 3.1 10 raised to power negative 2. And what is the velocity? Okay, you need to convert centimeter to meter. So 1.6 times 10 raised to power negative 2 meter per second. Clear? Centimeter to meter. Okay, 1.6 times 10 raised to power negative 2. Okay, solve. So you will get 3.6 times 10 raised to power negative 5 volt. Fine? Clear? Okay, so this is your solution for this question, and the major learning that how whenever it change, how everything is working. Clear, guys? Okay, now move to the next question. Okay, now we have the next question that is depends upon the Faraday law of induction, 9.3. Okay, I already separated them. These are the three questions I'm going to cover. Okay, 9.3, a long wire carries a current I. Okay, fine. As shown in the figure, okay, a square loop moves in the same plane, okay, as the wire as indicated. In which case will the loop have induced current? Guys, first of all, you need to think what are the factors of induced current. I told you V induced is equals to negative d phi over dt. Yes or no? And flux has three parts: B, A, cos of theta. We need to check either B is changing, A or changing, or cos of theta is changing. If any of the factor is changing, we can get the result. Okay, case 1. This is your case 1. Okay, body is going up, current is going up. Guys, just check in case 1. Case 1. Write like this: B, A angle. Okay, is there a change in angle? No. Is there any change in area? No. Is there any change in magnetic field? No. So the answer is no. No change. No change. So no current. Yes or no? No induced current. Okay, case number 2. Case number 2, it is going like this. It means change in angle. Theta is changing. At least theta is changing. Yes or no? Clear? Even in this case, third case, can I say B, magnetic field is changing because it is going away. It is going away. So it means the things will change. So can I say option 2 and 3 will give you the result. Fine? Okay. Next question. A circular coil, okay, of wire with 20 turns. So 20 turns means capital N is the number of turns. Okay, so this is 20, and a radius, okay, r is equals to 40 centimeters. Convert this 40 times 10 power negative 2 meter. Okay, highlight them. Radius is given, is lying flat on a horizontal table as shown in the figure. There is a uniform magnetic field extended over the entire table with a magnitude of, what is the value here? B is equals to 5 Tesla. Okay, and directed to the north and downward. Okay, north and downward. The diagram is given here like this. Okay, fine. Making an angle of 25.8. So guys, just tell me, is your theta equals to 25.8 degree? Yes or no? This is most challenging thing. Is it correct? Is it correct? I'll tell you a short form to solve with the horizontal. What is the magnitude of magnetic flux? So what we are looking for? We are looking for flux. Clear? So flux is very easy now. We know the formula of flux, B A cos of theta. Yes or no? Okay, the first thing, guys, you need to understand angle is given between. I told you earlier number of times that theta is the angle between n cap, which is the normal vector, and magnetic field vector, B cap, magnetic field vector. Yes or no? If any angle is given, okay, this is the shortcut, huh? That is very, very important. If any angle is given with area, then you need to find theta is equals to 90 minus 5, or 90 minus any other angle, or you can say alpha, beta, alpha. Do you understand? This is the way you can find easily. This is the shortcut for you. So what is the angle given here? 25.8. So theta should be equals to 90 minus 25.8. So you can check what should be the value. Okay, this is your answer. Clear? This is your theta. So now find the value. Flux is equals to, okay, there is a number of turns also. So we have B A cos of 90 minus 25.8 degree and the number of turns. Okay, now solve it. Number of turns are number of turns 20. So just 20 multiply 5 multiply, what is your area? Pi r square, pi, what is the r 40. So 40 times 10 raised to negative 2 whole square, and cos of 90 minus 25.8 degree. So guys, once you solve this, you will get 26.77. This is your value. This is the value of flux. Clear, guys? Okay. Now, in the end, we have the last year questions. So you need to focus that which kind of questions are there. So the first question, which of the following is a correct unit of magnetic flux? So we learned till now fluxes. What is flux? B A cosine theta. Yes or no? If we find from this, B is Tesla and A is meter square. This is your flux. You can say the first. Second, we know V induced is equals to negative d phi over dt. Yes or no? Take this side. So negative d phi is equals to V dt. If we solve the unit, volt second. Yes or no? Third, we know flux is equals to Weber. These are the units. Okay, just check. Okay, in terms of H also, what is H? H is Henry. Henry is the unit of inductance. Inductance means L. Okay, we have one more formula. Flux is equals to Li. Flux is equals to Li. This one you will learn in inductance, mutual inductance and the self inductance. So L here, flux is equals to Li. So can I say Henry times ampere? HA, where H is your Henry and A is your ampere. Okay, now just check this. Henry second per ampere. No, it's Henry ampere. Volt second. Yes, correct. Volt second. Okay, Henry multiply ampere is correct. And Henry divided by ampere, not correct. Tesla meter square. Multiply, not divide. This is also wrong. So the correct answer is your volt second. Clear, guys? Easy. Okay, next question, and I already covered the answer for this. All the means exam questions I covered the answers. Okay, this one is the interesting one, and this is for MCQ 3 also. There is a question, and what is the major focus point? As per MCQ 3, he is focusing on all the three equations what you have learned. So as per this question, when can we use the following equation to find the induced potential difference? Okay, we have this equation. V induced is negative B. As we know, what is V induced? Yes, negative d phi over dt. And what is flux? B A cosine theta. So as per this question, can we say B and theta are constant? This is constant value, yes or no? This is constant value, yes or no? So can I say phi, bring B cos of theta outside and keep it A here. So if I say V induced negative d phi over dt, then I can say negative B cosine theta dA over dt. Yes or no? Okay. So when we can use the following equation to find the induced current? So A and B are constant. A and B, no. AB theta, no. Theta and B, yes, theta and B. So your answer C is correct. A and theta, no, because A is a variable. A is your area. Area is a variable quantity. So in that case, your magnetic field B and theta is constant. Clear, guys? So this is a type of approach. So whenever the numerical will come, you need to just think that what exactly the question is going to ask you. So read carefully 2 times, 3 times, so you can solve easily. Okay, guys. So till here, I covered question number 1. Okay, that is in the previous video. Question number 2 and 3. So just practice so that you have a complete and clear idea for all the questions you can solve in the exam. Okay, guys. Till then, take care. Bye and keep on practicing.